questions before we start? Questions about anything? Questions about working in the software industry? Questions about your future? Questions about the coursework? Questions about the lecture? Questions about the tests? I still have some leftover Halloween candy. So anybody that makes a comment or a question, you can have some leftover Halloween candy. Nobody has questions or comments? Okay. That's fine. Okay, so some of you might have read the coursework. Hopefully you've all read the coursework by now, from start to finish. If you haven't done so, like, you're behind already, and you should start that. The coursework mentions these build tools, Maven and Gradle, and so we're going to discuss those today. We're going to give a little introduction to Maven and Gradle. If you have any questions or comments, feel free to interrupt at any time, including questions or comments from past lectures and future lectures. By the way, Pierre is going to go into more detail about GUI development next week, and especially on Java effects, like Java Swing and Java FX, because I noticed there are a lot of questions about Java Swing and Java FX in the labs, which is good, by the way. So you're going to hear about that in more detail next week. Okay, so we're just going to talk about these build tools today, Maven and Gradle. So Maven is a kind of project manager, if you want to call it that, both Maven and Gradle. So they manage projects. You're working on a project now, the Snake project. They manage dependencies. So dependencies is often when you use an external library. Right, in the Snake game, I think you're using an external library. I can't remember what it's called. And so-called artifacts. We're going to talk about creating a Maven build file, issuing builds, managing dependencies, multi-project builds. And specifically, we're going to always be thinking in the background a little bit about IntelliJ, which is our chosen IDE for this module. No pun intended, and reporting. So what is Maven? Maven, by the way, and Gradle sometimes. They're both build tools, which mean they manage a project and they compile it from scratch, or they manage the compilation process, but they also manage other parts like testing, deployment, and so on. Maven builds are structural. They manage dependencies. So I know in like yesterday's lab, I was working on some dependency issues with some students. A lot of the questions in yesterday's lab were just about dependencies, like how to import a library, how to get it to compile some external libraries. So this is one of the things that Maven and Gradle do. They manage dependencies when you want to use an external library. For example, a jar file, very common to use. And you can use external libraries in this project for multiple purposes. There are millions of external libraries, actually. It's mind-boggling how many there are. And you can also use them to manage your repositories. right? So those are your local copies of projects, and then eventually you use version control and you push them to GitLab, right, and share them with other people. In a real project, you're working as part of a team, so you're like, the typical workflow is you begin the day by downloading the latest version of the project, compiling it, running it, make sure it actually runs. And you're getting the updates from your other team members. That's usually how you start your day, typically. And then you work for some time, maybe a day. Maybe you added a new function or some new functions, or maybe you fix some bugs. Then you commit your changes and you upload them to the server, right? And then all of your peers can download those enhancements or fixes the next day. That's typically how it works in a software development project. But you wouldn't want to upload anything at the end of the day if it's not working, right? Maybe it's not working, or maybe you decide in the middle of the day you have a new function and you just want to save it as a version and then push it to the repository, push it to the server, commit it to your local repository and push it to the server. By the way, the implications of that are, what happens very often is somebody will push some new enhancements or bug fixes to the server, to the main software project. The other developers download them the next day, and then everything breaks. That can happen quite frequently. Yeah. Does anybody here have like experience in industry, in the software industry at all? Sean, what is your experience?
I did some web development where we made working on a website that helps people get their pilot's license.
It helps people get their what license?
Pilot's license.
Pilot's license. Cool. Very cool. There's no interview. Nice. Very nice. Did you use version control in that project? It's a good idea to use it.
It was a very small team.
Okay. Okay, so this is what the sort of project management structure looks like in Maven. So there's a so-called validate phase, there's a compile phase, there's a testing phase, packaging, that's for deployment, installation, and finally actually releasing the software for somebody else to use. Right? That's eventually what happens. So Maven builds follow a lifecycle using phases. Right? Each lifecycle phase includes the one above it. So the package starts with compile, then test, then package. Plugins can customize or hook into the phases. Right? You can also have some optional steps here. And as a bonus service for you guys, I have given or constructed a screen capture demo of setting up Maven and IntelliJ. So I just did this I think a week ago or something like that, where I used the latest version of the Mac OS. Actually, the Mac OS, funny enough, did anybody just update their Mac OS? I think I just updated mine to 13, I think yesterday or 2 days ago or something like that. So this is already the previous version of the Mac OS, even though it's only a week ago. Anyways, that's a screen capture demo that shows actually how it's working in a live demo on Moodle. So the link is available on Moodle. So you can see how it's really working as opposed to just me showing you a bunch of slides. John?
So what is the thing with the Maven thing? If you're doing compile, do you also have to do the test child, or does it just do everything above it?
Just above it, yes, that's right. And in the screen capture demo, you can see me, demoing some of the functionality. It's also from scratch, so like I'm downloading software, and you see me installing software, so it's as if somebody's never done it before, right? And I was able to do that because I reinstalled my operating system like a few months ago, and I'm doing everything from scratch again. I didn't do that like just for this module, just by coincidence. So yeah, that should help. And it is a little bit tricky. There are always tricky parts. For example, I had to rewind to an earlier version of the SDK. I couldn't use 19, I had to use 17. I couldn't get it to work with 19. And I had to make multiple attempts. The screen capture demo only shows the successful attempt. I think it was my third attempt, but I think I made 2 or 3 attempts before that, like where things just didn't work. That's true about all of my screen capture demos. So you only see like the one that works after the 3rd try or 4th try or something like that. So don't be surprised if something goes south during your setup process. Okay, all the information about a build is stored in this so-called POM file in Maven, Project Object, say that 10 times fast, Project Object Model file. And you'll see the POM file in the screen capture demo, me modifying it and adding a dependency. So it contains the configuration information about your project, like project ID, a list of dependencies, plugins, and a whole bunch of other settings. This is a screenshot of a POM file. It's quite an old, outdated one, actually, but that's the idea. It's in XML, pom.xml, so it's an XML file. So it has the ID. It has this link to some XML and W3 standards, right? And then it has this markup language, right? The model version, group ID, artifact ID, and so on. And then it has this list of dependencies. And in the demo, you see me adding the JUnit dependency, like how to add a dependency to the POM file. Okay, so Maven builds it starts out with a so-called project skeleton. So Maven uses its conventions to place files in the right places, and it sets up a special directory structure. And by the way, the directory structure of Maven and Gradle are very similar. Like they have a lot of things in common. So there's a pom.xml file that we just described. There's a source code directory, right, that has all of your Java files in it, and then test files, for example, unit tests, and then you have your executables in a target directory. So those are all your class files, Java files, and so on. And you'll see those in the screen capture demo as well. And Maven has lots of commands, right, like clean, compile, test, package, install, and deploy. IntelliJ adds a GUI on top of the command line interface. Like that's what you've seen already, right, several times for like version control, Git and GitLab. So it's adding a GUI on top of the underlying commands. So you don't actually have to know the commands or learn the commands from the command line. And Maven also generates reports. It's quite a complicated, I mean, IntelliJ is very complicated. I don't know if anybody knows that, but it is very complicated. There are so many user options. And that's true about Maven as well. Maven can generate lots of reports too. And I have not experimented with these reports, but they look really interesting, right? So there's something about a programming mistake detector, right? Report a source code analyzer for finding common flaws. Hopefully everybody looked at the debugging lab yesterday and started applying some of those debugging tips. A lot of the questions I was getting yesterday during the lab, when I was getting the questions, I was thinking, oh, if you looked at these debugging guidelines, your life would be so much better. Like, if you followed these guidelines, you'd be on the path to success. Right, there's a code testing coverage report, right, to find out what percentage of your code is actually being tested, right? There's a report on coupling between packages that looks at your dependencies. There's a report about the style, right, of your code, and so on. So lots of reports are possible, right, to analyze your source code. That would be a good exercise to run some of those reports on the snake game, but that's a little bit beyond the scope of this module and this coursework. So one of the main features is managing dependencies. So this is when you're using some external library to support your program, right? Like the JUnit library, for example. So the coursework asks you to write a bunch of JUnit tests, right? And so you can import a JUnit library to help you do that. And this is one of the things that Maven and Gradle do, are manage dependencies. In the screen capture demo, you see I add the JUnit library. That's the dependency that I add. So we can build projects that depend on other projects. We can build parent projects that build child of projects, and so on. And this is all managed via the dependencies tags, right? Those are in the POM file. Hard to remember all that. So this is an example of adding the JUnit dependency or the JUnit library to a Maven project. Right? There's a dependency tag, there's a group ID, there's an artifact, there's a version, and so on. And this is actually the dependency that I demonstrated in the screen capture demo, actually adding it to a POM file in IntelliJ. Has anybody looked at the IntelliJ YouTube channel? Has anybody looked at that? Two people? I highly recommend looking at it. That's what I'm looking at when I'm trying to run some Italian. So when I create my screen capture demos, I look at the IntelliJ tutorials first, so I can see what's going on myself. And they do a super job at their tutorial videos. They're really professional. It's really impressive how professional they are, actually. They add these effects, like they'll zoom in on a portion of the screen. Did you guys notice that? They'll say like, oh, focus on this portion of the screen, and they zoom in on it and highlight it and stuff. So it draws your attention to different parts of the screen. It's really impressive, actually. So they're working hard on their tutorial videos, and they're up to date too. So it's really impressive. They have some people working full-time on those tutorial videos. Okay, so there are lots of dependencies. If you do a search for dependencies in Maven, there are many of them. And there's probably something for everything. It would be a fun exercise to see if there are kinds of libraries that you can import for design patterns. That would be a fun exercise to look for design patterns in those libraries, in those external libraries, things like MVC or the factory pattern or the singleton pattern. That would be interesting. So you can split out the reusable functionality into jar projects or jar files. Right? You can create top-level projects with a POM targets, which coordinate the build of subordinate projects. You can manage your own projects, your own company repository, and so on. It's very complicated, like it's very feature-rich, so we're not going to go into all the details and all the features. It's just to give you some exposure to these build tools, really. We don't talk about multiple projects. We don't cover all the plugins because there are so many of them. But this will get you started. Any questions? Has anybody tried Maven yet? I think some people tried it already when I was getting feedback in the lab yesterday. Okay, Sean, do you have a question?
Why would we use Maven or Gradle over just writing a shell script that can do all of this and it doesn't require like the user, which is like the programmers, to install more stuff?
It's supposed to make it easier. It is complicated. I think though, after you get over that steep initial learning curve, especially like just the setup, it does get easier. Yeah. This module has a lot of kind of what I would call administration. I actually don't think of this as software development. All these tools, in my view of the world, fall under the category of administration.
Because you do this once with it.
Exactly. You set it up once and then you move on and that's it. And you forget about it, basically. And that's one of the reasons why I did these screen capture demos. Because I don't think we should spend the majority of the time actually trying to get the tools to work. I think the actual software development is the more important part. So yeah, when you start a new job, you spend, the first thing you do is you say like, do I have a computer? Right, and then the company might say yes or no. Usually they'll say yes. But usually you have to like place an order, so they'll place an order for a computer and then you wait for your computer, and then when it finally arrives, you spend a few days setting it up. So you're talking to the other developers, you're talking to the configuration manager, you're talking to the tech support, just to set the thing up. Install all the necessary software, get version control working, get the IDE working, download the project, just compile it, see if it runs. So you spend a few days just doing that at your job. I had a job some time ago where I arrived and I said, like, do I have a computer? And they said, not yet, we're going to order new ones for you. It's me and a colleague that were starting at the same time. And I said, okay, that's fine. And they put me on a temporary machine. And so you don't really, you don't get excited about using somebody else's machine that they left behind and you know it's only going to be temporary, so you don't feel like investing a lot of time and effort into setting it up. If you know what I mean, because you think, well, I don't want to invest too much time into getting this machine the way I like it, because I know in a few days it's just going to be swapped out for a new one. So I got a used machine, and every day I came into the office and I was wondering, like, I wonder when the new machine is going to arrive. And I was working in an office and there was a hallway, a big hallway, and I noticed there were 4 huge boxes, like just cardboard boxes, very large ones, like half the size of this table, right? And this was a new company Like, I was a very new employee at a company, right? So when you're new, you don't really like to question things too much, right? Anyways, I walked by every day to my used computer in the office, and I walked by those boxes, and I always wondered, like, those boxes look like they could be new computers. But I was like, well, if that was my new computer, somebody would let me know, like my manager, for example. And I waited about 4 weeks, I think. And after 4 weeks, I said, like, that's not my new computer, right? To the manager. And the manager's like, let me find out. And it was like my new computer had been sitting there in a box for about a month before I got it. Anyways, something like that, it's unlikely that something like that's going to happen to you, actually. Very unlikely. Okay, so the other tool we're going to talk about is Gradle in even less detail. So that POM file that we saw, it was written in XML, like that project object model file. The Groovy uses Gradle uses a programmable language file based on Groovy. So you can actually add some logic to the object management file. Like you can add conditional statements, and for loops, and decision making. Right, so it's more customizable. So Gradle replaces XML in favor of a domain-specific language called Groovy. That's a programming language, therefore it can implement flow control. It can act as a build manager for other languages, right? It doesn't have to be Groovy, right? It manages dependencies just like Maven does. And it handles the tasks required typical of development project, right? From compilation, testing to deployment. And it's the official build system for Android. Android's pretty popular. So the Gradle build cycle launches as a new Java virtual machine process. So it parses the Gradle.properties file and configures Gradle accordingly. It creates a settings instance for the build. It evaluates the settings.gradle file against the settings object. It creates a hierarchy of projects based on the configured settings. Finally, it executes each build Gradle file against its project. And again, this is a little bit theoretical when you're just looking at slides. So I was working on this this morning, the screen capture demo for Gradle. So I just actually made that this morning, and I put a link to it on Moodle. This one in the slide is actually last year's. So the Gradle demo that I made today is really the latest version of Mac. That's Mac OS 13. And the latest version of IntelliJ. But it's not the latest version of Java, so I have to go back even further in time to Java SDK version 11 to get it to work. So you're welcome to play with that and see if you can get it to work with a more recent version of Java or the SDK. Even I cross-referenced the setting up Gradle in IntelliJ on the IntelliJ YouTube channel, and they also say you have to go back a few versions to get the officially supported Gradle and Java version together. So I wasn't sure about it, so I cross-checked. So it even says here, pay special attention to the JDK/Java version used. This link is to last year's screen capture demo that I did. The one on Moodle is to this year's version. And maybe some of you noticed that all the stuff I'm doing this year is on a playlist called Developing Maintainable Software 2022. Did anybody notice that playlist? Nobody noticed that? There's a link to the playlist on Moodle, actually, if you didn't notice. There are lots of tutorials. When I look for tutorials on any of these tools, I look at the IntelliJ YouTube channel, actually. That's where I find mine. But there are lots of other ones too that are connected to other IDEs or other programming languages or other scenarios and other settings, or independent of any special technology. Okay, any questions about Maven and Gradle? I encourage you to look at the screen capture demos, and I actually added some voiceover to those to make it a little bit easier. Sean?
For the coursework, do you recommend using one or the other?
I think if I was going to do the coursework, I would choose Maven, personally, because I think, well, you can use a later version of Java with Maven. It seems like quite a step back to me to go back to version 11. It would be interesting to look up when version 11 was released. But that, like, maybe we can Google it right now. Okay, so it's not, I guess it's not that old. Okay, that's more recent than I thought, at least if I'm understanding that correctly. So I thought it would be older than that, like, I don't know, like, so it's not as old as I thought, actually. Any other questions? Oh, since I still have lots of leftover hiring. Any other questions, comments? Anything like that? Okay, I think we're going to end early then, if there are no questions. If everybody's happy, we can end early. If you're unhappy, you can stay here, talk to me until you're happy. Yeah. Does that sound reasonable?
At the debugging stuff, and you were saying you voice test improvements, so you're saying that you can't say if is odd equals false. So you're saying you shouldn't say you can't
That's
say
right. That's right. You should always be testing for truth. You could always take that negative test and turn it around into a positive one. And then what do you say? So, like, take this condition that used to be false, turn it into a positive case. And if it tests positive, do nothing. Otherwise, do something. You know what I mean? So yes, those negative tests are very confusing. And I see developers using double negatives. It's horrible. It's horrible. So, ever since...
positive and a negative. Say have two different variables, one that's like the positive.
Something like that. Just avoid negative tests. It's like, because they're so confusing. Especially when you're reading other people's negative tests. I could have added test for the presence of something rather than the absence. Like, for example, you wouldn't want to say if not null. If not null. do this, you would say, if it's no, spit out a warning, otherwise proceed. See, like what version of that might be the problem.